with a photo from Australia, our recent bushfires, and they are terrifying. I think there are a lot of stages in life that can be terrifying, and trying to reintegrate into society is important. But today my topic is use of maintenance values to improve slip resistance architectural specifications, maximise productive life cycles, and further enable the development of building codes. Because with so many of us, what we're trying to do is to improve the built environment to make everywhere safer. So I have several slides. Hopefully I'll touch on some of what's in my written paper, but there's so much more I would have liked to have shared with you. Okay, so that's me, but yeah, flying embers are a scary thing. So, fundamental question, how should governments protect the public? And, what can we do about the environment generally? Now, building codes are an element of the solution, and they initially had a focus on fire and on structural safety, and they will always have that as a primary focus. But we know that properties can be better designed, built and maintained. So what we have to try and do is to provide the information to enable that design and to facilitate the building and to give the correct advice when it comes to the maintenance. And that way we can provide the built environment. So when it comes to optimising building codes, there are several people who sit on building codes committees. It probably varies a lot from country to country. In Australia, we have different state governments being represented. We have our academic research institutions being represented and various other organisations. So if I talk to the Executive Director of the Australian Building Codes Board and ask him to do something, he can legitimately say that he is powerless. He has no authority because he doesn't make the decisions. So in dealing with any organisation, who makes the decisions? You have to talk to lots of different people and persuade them that what is being said is the appropriate thing. That's in part why I mentioned seduction, that as with politicians, they are given so many competing versions of the truth or the potential benefits. So codes are about weighing up those costs and benefits and certainly setting minimum requirements for design and construction. And nowadays we favour performance-based codes that theoretically specify how a building must perform, because it's one thing to specify and say you must do this, but we have all sorts of difficulties in constructing to those standards. So building regulations are each subject to cost-benefit analysis. They must demonstrate a cost-benefit, and the cost-benefit or the cost of compliance should be less than the benefit delivered to the community. But all of this should be based on reliable data. And when it comes to slip, strips and falls, there's a lot of unreliable data. A lot of people say that they've fallen because they don't know why, or they've slipped because they don't know why they've fallen. And it's not a genuine slip. So as soon as people start mining databases using computers to go through to record the extent of injury, they will often pick up a lot of examples of slips where the person has not really had a slip at all. So where is the reliable data? When it comes to measurements of the built environment, we may have laboratory testing organisations who go out and make measurements of the slip resistance, but all of that data is privy to their clients. It's something that is difficult to share with the rest of the world. Insurance companies may be able to release some material, but there's not enough material getting out there. And by and large, a lot of the data is, I believe, in error. And when we have a look at people putting video cameras into aged care facilities and actually recording hundreds of instances of people falling over, we find that 2% or less of them have been due to people actually slipping. So the falling over becomes a natural part of life when we have the elderly and people who are losing their balance, because loss of balance is the primary cause of falls in the elderly. We have different causes when it comes to people at work. So we need to look at all of the data very carefully. In Europe, you now have a legal requirement that floors must be safe, i.e. slip resistant, at the end of an economically reasonable working life. We can criticise governments for many things, but certainly not for this. And the intention was announced in 1989, and it was regulated in 2011. The relevant slip resistance committee that was alluded to previously started work in the middle of 2001 with instructions that they should be producing a single test method rather than a multiplicity of test methods. I've addressed that in other papers, and I address it slightly in my written paper. Now, I'd like to just start by summarizing the Spanish Technical Building Code requirements. That there are 3 basic classes that are called up, and these measurements are made both wet and dry. And we have, for class 3, we have a requirement of a slip resistance value with the slider 57 greater than 45. That applies to exteriors and swimming pools, as well as wet interiors with slopes greater than 6%. And I don't imagine that there are too many of those. I mean, we do have some ramps in buildings, but by and large, most of the floors in buildings are level. It also applies to internal stairs, but I appreciate that these apply to industrial situations. We have wet interiors with very mild slopes, and that's class 2, and dry interiors with slopes that are again mild. Now, the relevant document that's called up in the building code, the SUA, Security of Use and Accessibility, was recently modified the 20th of December last year. That is now specifying the Spanish standards for pendulum testing. There are separate standards for wet and dry pendulum testing using independently sliders 57 and 96 respectively. And we have the requirement under the code that the mandated class shall be maintained for the life of the floor. There's a supplementary or comment document that contains useful guidance, including provisions for dealing with the transition zones between wet and dry areas and other circumstances that aren't detailed in the main document. And it also states in a couple of places that there's no correlation between the pendulum results and the German ramp tests, which is quite true and relevant, and I don't think anybody would question that. But it's important that architects recognise it, because the guidance documents permit products classified as R11 or B for the wet barefoot test. They state that they're suitable for any conditions set out in the table that I showed you previously without the need for pendulum testing. And that can make life difficult if you have long-term requirements. It also lists flooring materials considered to be safe without pendulum testing, including natural stone with flamed and bush-hammered finishes, some concrete products, and clay pavers. And there may be accepted definitions, but there may not be. There may be questioning of definitions. Should this be tested? Should it not be tested? So you can start to see the potential problems. In Australia, we have similar codes, but I think that with most national codes, the objective is to provide people with safe access to a building and the services and facilities within it. Our deemed to satisfy measures are only extending to ramps and stairways at the moment. There's uncertainty with our work, health and safety laws. They have also, similar to the Spanish Building Code, ongoing requirements that it must be safe. The National Construction Code has maintenance of essential safety measures. Is this mandatory? Is it not mandatory? Does it cover the entrances to buildings and the exits that must be providing people with safe access? None of that is really that well defined, and it needs to be. So I would challenge some of our deemed to satisfy situations. They are over the top and too demanding for a lot of situations. And that applies to both residential as well as industrial and commercial. One unusual feature of the Australian standards is that we have separate testing standards for new pedestrian surface materials and the measurement of existing pedestrian surfaces. That was done specifically at the request of our Australian Building Codes Board. The government owns a lot of property, and when we stated that a pendulum value of 39 would define wet slip resistance in an earlier standard, they suddenly thought, well, half of what we own or more does not comply with the standards. Are we legally liable? So they asked that it be separated. And one of the unfortunate aspects of that is that you only ask that the building be slip resistant when new, rather than having that ongoing requirement, because you've got separate tests and things like that. So that's one of the problems that we have in Australia. We use two rubbers with our testing. We use the pink lapping film preparation nowadays. Again, I think that we should be having a requirement for P0 at the bottom end of the scale, because where people use Slider 55 rubber as a surrogate measure of wet barefoot slip resistance, if you don't have the bottom stage, it makes it difficult to use the one above, because it includes products that you don't want to be used in wet areas at all. So nobody's perfect, nothing's perfect, but what we try to do is to make things better than they were before. We're never going to start out with a perfect system, but we can start somewhere. We have to start somewhere. This is coming back to some British work in the 1960s, where it was done at the Building Research Establishment. In determining the risk of slipping, that's not what they set out to do. They set out to determine an accelerated wear conditioning method for various types of floors. And they concluded that that's impossible, in the same way that we've concluded that it's impossible to have a single slip resistance test method that is going to give relevant results for every material in every circumstance. And we have to accept that with accelerated wear conditioning in the same way that we have to pick the right methods of conditioning, just as we have to pick the test method that is most appropriate to determine the slip resistance for the situations that we're looking at. Now, I've tried, just as a challenge, to combine the Spanish and the Australian classifications because slider 55 and slider 57 are often considered to be identical, and slider 55 is generally used as one of the two rubbers for slider 57. And I've used from the previous slide the traffic light system, where we had before the risk of 1 in a million as being safe, effectively at a coefficient of friction of 0.36, and below 0.25 would be unsafe. So I've applied a similar logic in grouping together these values, assuming that you can divide roughly by 100 the pendulum values to give you a coefficient of friction. And we can see that there's some degree of equivalence between class 3 in Spain and P5 in Australia. Class 2 in Spain would be equivalent to class P3 and P4 in Australia. And class 1 in Spain would be equivalent to class P2 and P1 in Australia, which is where we see there's some materials we would consider safe or marginal and others definitely unsafe. So it would be good to maybe in the future get some closer agreement there. But my other point with this slide would be that if you are at the bottom end of the range and at the top of the one below, a value 25 and 24, for slider 96, let's say, there is almost no difference in the slip resistance, but there's a big difference in how you are classifying the product. So while you might say, oh, we've got a P2 product or a P1 product, people might say, you shouldn't have P1, it's not going to be safe enough. But for 1 BPN more, you know, the P2 product is going to be just as unsafe. So our reliance on using classifications and not identifying where products are in classifications is a little bit short-sighted. Here I have taken some of my old work and recycled it. And we had 5 different types of polish on one granite finish. And we took the 2 sliders, 55 and 59, which were traditionally the European sliders. What I probably should have done was to have got a slider from BAM rather than from RAPRA, but they were both from RAPRA, because I'm interested to see the difference that people are getting in results between using the 2 different sources of slider. I've not seen any published information on that. I'm sure that a lot of people have done some work, but nobody's published it. So maybe that's a role for the slip resistance group of Spain, the UK slip resistance group, or whoever is interested in trying to get good data out there. But in some of the European stone standards, you were allowed to use grade 60 sandpaper for preparing the slider. In Australia and previously in England, we would use P400 paper, and we were looking at the transition to lapping film. And I think you can see that there's a big difference in the results that are obtained, but how do we then convert these results into coefficients of friction to determine what's safe and what's not? Because it's the same material, it's just a different number. So when it comes to coefficients of friction and the risk of slipping, what do the numbers mean? And I've not seen any publications that relate to that. So we're not getting to the end of the work, we're just identifying some of the things that still needs to be done. Which method, which technique provides the best indication of slip risk? There are too many people who say, oh, we've got the perfect thing. No, everything's capable of improvement. The Australian method of accelerated wear testing was developed by Carl Stroutens, who's here with us in the audience. And so simple, so elegant, and so bloody frustrating, excuse my language, after having tried to develop something simple and elegant myself. So after being frustrated for at least 20 years, thanks Carl, one of the things about the results that you get is the very rapid initial decrease. Carl looked at several pads before selecting the one that was here, that's shown commercially, or is available commercially. So it's a simple procedure. It now has accreditation from the organisation that accredits laboratories in Australia. And McDonald's Australia selected a requirement, or adopted a requirement, of 35 ppm after 500 cycles as being appropriate for their stores. So rather than taking a product and selecting it on the basis of its ex-factory slip resistance, they would have the products, the candidate materials, being subjected to this test, and they would then select something anticipating that it would be giving results sort of down here on the plateau rather than in the sharp decrease pattern. How long does, or how much traffic does 500 wear cycles equate to? We don't really know because we don't have enough data. But I think McDonald's are happy with the products that they've been selecting, so it's good in that respect. I mean, what happens in the real world? Now, last year at ITC in Castellón, Munoz summarised maybe 15 years of work in the laboratory, maybe more, in her thesis. So I'd like to just say there is some data, so there's some good news. And she looked at more than 54 types of tile, but because the work was done over a long period of time, there's not the same data that's available for everything, because there are limitations with specimens and things like that. But she used a very simple criteria for grouping the specimens together that are listed here, sort of smooth and then becoming progressively rougher. And she looked at several different things. I've just picked out a couple of slides. Again, there is no direct correlation between wet and dry, wet pendulum results with sliders 57 and 96. So we can put other sliders in there, and again we would expect the ranking order of slip-resistant materials to change, and that reminds us of the critical importance of footwear and again the condition of the footwear. We often, well, it has been said that there's good correlation between wet barefoot slip resistance as measured with the German ramp and slider 55. There's an acceptable, let's say, degree of correlation there at 0.69, but it's not very good. And when we think, and I'm just now trying to remember what the tangent of 18 is to give me the B equivalent, but let's say that, okay. I went back before. No. I think I'm just digging a deeper hole. Okay. It's a different keyboard. Glasses always help. Yep. How do I just go back to the slide I was on?
Go back where?
To the slide that I was on? Ah, okay, I've got to accept. Okay, that. Yep, good. Thank you. Okay, we can cut this bit out of the recording. But I think you can see that if we were to take 0.35 or draw two lines anywhere, we can see that some products are going to be in what we might describe as Class B with the German wet ramp test, and they're not going to be covered by the Class 3 requirement with a 45 to be in excess of 45 BPN or 0.45 on here, rather than anything that comes below is going to be regarded as being slippery. And yet if we've got, because it's easy to see 0.3 coming in, anything below is not, definitely not a Class B tile, but anything above is. So we've got some materials, let's say this point here, that might be a Class B tile, but it's certainly not going to meet the Class 3 requirement. So that's one of the perils of using two different methods of classification. We've had that in Australia, where we've had the German ramp tests and the pendulum test since 1999, before the European Committee was even formed. But we've found, you know, some good things, some bad things, or unfortunate things, not bad. One of the major aspects of this thesis is looking at accelerated wear as against real world wear. And here we have two different locations, the same material being installed, and the number of people that have walked across the floors. So this is real loss of slip resistance. So we can see that this product was initially Class 3, and it is now Class 1 after 400,000 people walking across it. So that's maybe an economically reasonable life cycle performance, but you have gone from an area of being acceptable. Is it dangerous? Probably not in the circumstances. I think that this is in two entrances to the building. It's a matte glazed porcelain stoneware with imitation stone relief type 1, which is just an indication of the classification of this tile according to that system. But anyway, so there is some real data. This is again looking at different tiles, and here I've put some lines in to differentiate between classes 3, 2 and 1, and we can see products that are falling. This product with the purple one is falling from Class 3, where it's well into Class 2, where it's spent most of its life, and it's now falling into Class 1. So it's great to have a long-term slip resistance lifetime requirement, but I don't think you can get that based on ex-factory slip resistance results. So what do we do about it? We can use accelerated wear conditioning procedures, and this method was developed in knowledge of Carl's method. It's basically using industrial polishing, tile polishing equipment, where each of the stages I think only takes 20 seconds or thereabouts. So it can be done very quickly, again using scouring pads, and we get similar results to those that were shown of Carl's work before. And again, this is the number of people for group 3 tiles. So we've gone from the last slide where we were using group 2 tiles, which are essentially smooth with maybe a little bit of gritty feel, to group 3 tiles that have now got a wavy surface. So they're maybe a little higher in slip resistance. And here we have 4 surfaces. This one's quite unusual, but the other 3 or 4, there are 2 here, the more what we would expect. Here we're getting into the group 4 tiles, which are more structured, and this is the accelerated wear compared to the natural wear. There's not as much data for some of the specimens as some of the others, but there is data for both methods. This is getting into group 5, which are the highly geometrically profiled tiles. And there's not as much data there, and I would assume that this is in part because you don't want to put in isolated tiles in various locations. You have to have whole installations and things like that. But when we look further, these are those 2 group 5 tiles, and this is giving you an example of the structured pattern, and we can see here, you know, the nature of the geometric profile, whereas here it's quite different. So we're getting a lot of data that's available. There's a lot of surface roughness, 2-dimensional mechanical profile contact data also in the thesis. And these are some of the other group 5 tiles that, again, some of these might be matte, some might be glazed. So by having that level of detail, we start to get a better appreciation of some of the individual results. And we can combine the accelerated wear conditioning slip resistance results with the number of people walking across the surface. And here we see that, you know, 2 stages is very closely equivalent to 20,000 people for this particular type of tile with this particular type of finish. So I've just put a couple of these in. They're not always identical, which would be lovely, but you know, we live in the real world. But again, we get an indication of the type of surface, the type of finish. This is a wavy surface, class 3. But so that's real data, whereas some of the fake news and things like that that we often see, I'd like to draw attention to Gonzalo while he's still awake. But no, Gonzalo has had a lot of association with all of the work I've just shown, and he can answer far more questions than I can, so please don't direct any questions to me. Gonzalo will be more than happy to answer them. But Gonzalo has also been working with footwear and other abrasion techniques that may relate better to internal, external environments and things like that. So there's a lot that can be done. So Marcel, you've contributed a tremendous amount over the years, and I would like to take exception to some of the things that at times I'm sure they're accurate, but you know, where you say the pendulum can overestimate actual slip resistance due to stiction effects, I think you should publish at least a paragraph on that rather than a phrase, so that people don't misinterpret it. And again, when you say the impact profile, the impact variation on the profile with the pendulum needs attention. So I thought that this was a good opportunity. Well, I've put that material further down in the presentation. So I have 5 minutes left, which is just right. I won't get to that material. It's in the paper. In 2011, before we even adopted the pink lapping film, I made a proposal that we consider having maintenance values to assist with the interpretation of test data for the measurement of existing surfaces. So if we had a footpath, let's say the top example, was it giving a result of 35 or not? Because this might be assessed as being what was required, whereas the guidance in our handbook might be saying you need BPN of at least 45. Do we draw the line at 35 and leave it at that? So in Handbook 198 that came out in 2014, once we had adopted lapping film, the requirement was put in at 45. So the values in the middle column were my guesstimates as to what should be. The one big difference that you'll be able to see is for residential bathrooms, toilets, kitchens and laundries. We have no requirements in our guidance because some people don't want people to have guidance, which is unfortunate. But we now have a new document that is looking at the housing for people with disabilities and some recommendations that have been made, and that document has a recommendation of 35. Is that too much? Is it too little? Might it have been 25 if there had been some guidance in the handbook? I don't know, I can just speculate. But anyway, we need to know what level is required at the end of an economically reasonable service life. We have to come to some degree of agreement there, and we need to study the falls data where measurements have been made of people falling over. What is the level of slip resistance? Because we don't have that data. We've had government studies funded in Australia that I talk about in my paper, and they came up with no data at all. So let's get the full value from the accelerated wear conditioning results. Let's assume that the procedures may cause wear that might not occur in the real world. So if we take 500 cycles, that's going to present a reasonable indication of long-term wear. Now, this proposal was made before looking at all of the information that I've just presented. So I reserve the right to modify what I presented prior to being better informed. That's how we develop better standards. But again, I said at this time, let's call these maintenance values. They could be used as a minimum value for specifications, as a critical point for on-site audits, but also they can be used in conjunction with accelerated wear conditioning for specification purposes. And I took existing classes that we have, and these are the minimum acceptable values for slide 96. And I said where we have a P5 requirement at the moment, let's just suppose that we should have a class M5 requirement, and that you could still use the existing system if you want to, but if you wanted to, you might go to a system based on maintenance values where you would be saying, I want a minimum maintenance value after 500 cycles, a BPN of 40 for anything that was P5, or for P3, instead of 35, I might accept 27 after accelerated wear. Because I might be quite comfortable knowing that if I was to select on that basis, where none of my 5 specimens in Australia, different in Europe, had a value less than 22, so here we're talking the minimum mean, but I could be quite comfortable that that product is likely to give me an economically reasonable life cycle performance, and that it's going to be at 27 or above sometime, a long time in the future. And I think that that is maybe what you should be looking at in Spain, where the slip resistance group may be able to, through its members, get together a lot of the test data, and you can either use a carrot or a stick to encourage test houses to provide that data. Are you going to reward them for providing it, or are you going to penalise them if they don't? But, you know, if it exists and if the government is interested, it can get the information. It can always. So why not do it? And I would make a suggestion that with all of the data that's been accumulated at ITC, why not go ahead and see if you can develop some more appropriate classifications. So if you can work out what the level of slip resistance is in the existing environment, if you can work out from the falls data, again, the government can have a requirement to maybe have some of the falls investigated. What was the level of slip resistance? You know, in organisations that are having falls, please, you know, we want to gather some data. You now have an obligation for the next 2 years to have the slip resistance measured. You may even reduce the number of accidents because people don't want to pay for the testing after the accident. Who knows? But anyway, you can easily get the data if you put your minds to it. And I think that the slip resistance group of Spain may be able to coordinate this on behalf of government. But I think that's my 5 minutes, so I'll leave it there, and thank you all very much for your attention.